So far we have seen what is meant by frame allocation, right? Now let's see the most important topic in operating system, which is nothing but page replacement. Okay, page replacement is very important topic. Let's see this. Let's consider this scenario so that you will be able to understand the concepts very well. Let us assume we have a RAM and we have three processors named P1, P2 and P3. And P1 has some 6 pages, P2 has 5 pages and P3 has 4 pages. See, it is starting from 0, right? So from 0 to 5 it is 6 pages. Now since we are using virtual and it has been told that process P1 has been allocated 3 frames. What does it mean? At any point in time in the RAM, process P1 can use only 3 frames. It cannot use more than 3 frames, right? That is what we mean by frame allocation. Similarly, process P2 has been given 2 frames and process P3 has been given 2 frames. Fine. Now we are using the concept of virtual memory here. What do we mean by virtual memory? We are not going to maintain all these pages inside the RAM. Rather, we are going to maintain only few pages. Why? Because it is going to increase the degree of multiprogramming. If degree of multiprogramming is increased, then the memory can be managed in a more efficient manner, right? You know that CPU efficiency will grow higher. Fine. Now here, since process P1 has been given 3 frames, we can maintain only 3 pages of process P1 inside the RAM, right? Now which 3 pages are we maintaining here? We have page number 0 of P1, fine, page number 0. Then page number 4 of P1, page number 4 of P1 and page number 2 of P1, page number 2 of P1. We don't have any other pages, right? We are maintaining only these 3 pages of process P1 inside the RAM, right? Now similarly for process P2, we are going to maintain page number 4 and page number 1. See, process P2 has been given only 2 frames, right? So we cannot use more than 2 frames inside the RAM for P2. So they have told that page number 4 and page number 1 and page number 4 are maintained inside the RAM. Fine. Similarly for process P3, they have allocated 2 frames and hence we are maintaining only 2 pages of P3 inside the RAM. Now which 2 pages? It is nothing but page number 0 and page number 1. We are maintaining page number 0 and page number 1 of P3, right? Fine. Now this is fine. We are maintaining these pages, fine. Now in case if CPU requests for a byte in page number, let us assume now CPU is executing process P1, right? Our CPU is executing process P1. Now in case if CPU requests for a byte in page number 0 or page number 2 or page number 4, it is perfectly fine. We don't need page replacement, right? We can straight away take that byte because these pages are present inside the RAM, the page number 0, page number 2 and page number 4. And so in case if CPU requests for a byte in page number 0 or page number 2 or page number 4, it is perfectly fine. We will not come across page fault. CPU can take that byte from the page and then it can execute it faster. You know that, right? Now in case if CPU requests for a byte in page number 1, then comes the problem, right? Then there is definitely page fault. Why? Because see, all these page processes are present inside the hard disk, right? You can even assume that all these things are present in the hard disk. Fine. Now in case if CPU requests for a byte in page number 1 of P1, then what will happen? Since page number 1 is not present inside the RAM, this page has to be moved inside the RAM, right? Because CPU cannot access the hard disk directly, it can access only the RAM. So in case if we can move page number 1 to RAM, CPU will fetch that byte from the RAM, right? The byte which it needs from page number 1. Fine. Now how are we going to move page number 1 inside the RAM? That is an important point, right? See, one question I want you to ask here is, can I place page number 1 only in 3 frames which are allocated to P1? See, these are the 3 frames which are allocated to process P1, right? Now, I need to bring page number 1 inside the RAM. There is no other way because CPU has requested for a byte in page number 1. So, this page has to be moved into the RAM. Now, can I take this page and only replace one of these 3 pages, or I can replace any page I want, right? See, for example, can I take page number 1 and place it here, or can I replace process P3's page over here? That is the question. The answer to the question is what type of page replacement we are using, right? Page replacement are classified into two types. One is local page replacement, another one is global page replacement. What local page replacement says is, in case if you wanted to place page number 1 of P1 inside the RAM, you can either replace page number 0 of P1 or page number 2 of P1 or page number 4 of P1. You cannot touch other processes pages, right? That's what we mean by local page replacement, which means in case if I wanted to move a page of process P1 to RAM, I can only replace the pages of process P1. I cannot touch other processes pages, right? Since process P1 has been given 3 frames, I can place page number 1 only in the 3 frames which are allocated to P1. I cannot touch other processes. That's what we mean by local page replacement algorithm. Similarly, see here, in process P2, we have page number 1 and page number 4 inside the RAM already. Now, in case if CPU requests for a byte in page number 0, page number 0 has to be definitely moved into the RAM, right? Now, can I place it in any random frame? Can I place it in any random frame, or I can place only in page number 1 of P2 or page number P. See, these are the pages of P2, right? In case if I am using local page replacement algorithm, page number 0 can be placed in either this frame or this frame and not in any other frame. In case if I say that we are using global page replacement algorithm, then I can place it in any frame I want, any random frame, right? In simple words, I can tell that in local page replacement algorithm, page replacement happens only within the frames of a particular process, right? Whereas in case of global page replacement can happen across processes, right? Which means one page of one process can be replaced with page of another process. That is what we mean by that can happen in global page replacement algorithm. Now, among these two things, local page replacement and global page replacement, the most important thing is local page replacement. This is mostly used today. Global page replacement is no way used today. It is none of the practical implementations we are using global page replacement. We are using only local page replacement. See, the reason for this is, we'll see that later, okay? Why local page replacement is more important than global page replacement. So throughout this course, whatever I'm going to discuss, assume that we are using local page replacement, right? Which means in case if page number 1 of P1 has to be moved into the RAM, I can either replace page number 0 of P1 or page number 0 of P1 or page number 4 of P1 or page number 2 of P1. Because our process P1 has been allocated only these 3 frames, I cannot touch any other frame, right? Fine.